Our solar system is a vast and mysterious place. It's filled with planets, moons, asteroids, and comets, all dancing around a single star, our sun. How did this incredible system come to be? The story begins billions of years ago, long before Earth even existed. Imagine a giant cloud of gas and dust, a cosmic nursery where stars are born. This is where our journey begins. This cloud, called the Solar Nebula, was not just sitting still. It was spinning slowly, a gentle waltz in the vastness of space. This simple act of rotation would set off a chain of events leading to the formation of our solar system. The story of our cosmic home is a tale of gravity, collisions, and the amazing power of nature to create order out of chaos. The solar nebula, like all things in the universe, was subject to the laws of physics. One force, in particular, played a crucial role: gravity. Gravity is like an invisible hand pulling things together. In the vastness of space, gravity began to pull the gas and dust particles of the solar nebula towards each other. As the cloud contracted, it began to spin faster and faster, just like a spinning ice skater pulling their arms in. This spinning motion caused the nebula to flatten into a disk, a giant cosmic frisbee. This swirling disk, called the protoplanetary disk, would become the birthplace of our planets. Imagine the scene: a vast swirling disk of gas and dust glowing faintly in the darkness of space. This is where our solar system began to take shape. At the center of this swirling disk, something amazing was happening. The immense pressure and heat from the collapsing gas and dust caused the central region of the disk to ignite. This wasn't just any fire, this was nuclear fusion, the process that powers the stars. Our sun, a giant ball of hot, glowing gas, was born. Its powerful gravity began to dominate the surrounding disk, pulling in more and more material. The sun's birth marked a turning point in the story of our solar system. It wasn't just a swirling cloud of gas and dust anymore. It now had a star at its center, a source of light and heat that would shape the destiny of everything around it. While the sun blazed at the center, the rest of the protoplanetary disk was far from quiet. The disk was still filled with countless dust grains and larger particles, remnants of the original solar nebula. These particles, constantly colliding with each other, began to stick together. This process, called accretion, is like building a snowman. As you roll a snowball, it picks up more snow, growing larger and larger. In the protoplanetary disk, these tiny particles gradually grew into larger and larger clumps called planetesimals, the building blocks of planets. Over millions of years, these planetesimals continued to collide and stick together, growing larger and larger. The protoplanetary disk, once a chaotic jumble of dust and gas, was slowly transforming into a more orderly system. Section 5. Giants and Dwarfs, a planetary lineup. As planetesimals grew, their gravity became stronger, pulling in even more material from the surrounding disk. Close to the sun, where it was hotter, only rocky materials like iron and silicate could withstand the heat. This led to the formation of the inner rocky planets: Mercury, Venus, Earth, and Mars. Further out, beyond the frost line, temperatures were cold enough for ices like water ice, methane ice, and ammonia ice to remain solid. These ices, along with rock and metal, provided more material for planet formation, leading to the birth of the gas giants: Jupiter, Saturn, Uranus, and Neptune. These massive planets, with their powerful gravity, sculpted the outer solar system, influencing the orbits of smaller bodies like comets and asteroids. Section 6. Leftovers of creation: asteroids and comets. The process of planet formation wasn't perfectly efficient. As the young sun ignited, the surrounding disk of gas and dust began to coalesce into larger bodies. However, not all of this material managed to form planets. Not all of the material in the protoplanetary disk ended up in planets. Some of it remained as smaller bodies, scattered throughout the solar system. Between Mars and Jupiter lies the asteroid belt, a region populated by countless rocky remnants from the early solar system. These rocky bodies are the building blocks that never quite made it into a planet. These asteroids, ranging in size from tiny pebbles to dwarf planets like Ceres, are like time capsules. They offer invaluable clues about the conditions and processes that were present during the solar system's formation. Even further out, beyond the orbit of Neptune, lies the Kuiper Belt. This region is populated by icy bodies, including dwarf planets like Pluto and Eris. These distant objects are remnants of the primordial solar system. These icy leftovers are thought to be pristine remnants of the early solar system, preserving the chemical composition of the original solar nebula. They provide a frozen snapshot of the solar system's infancy. Comets, those icy wanderers that occasionally grace our skies with their spectacular tails, also originated in the outer reaches of the solar system. They likely formed in the Oort cloud, a vast spherical region that surrounds the solar system, extending far beyond the Kuiper belt. These comets are ancient travelers, carrying with them the secrets of the distant past. Section 7, our cosmic neighborhood, a look around. So what does our solar system look like today? At its heart lies the Sun, a yellow dwarf star that provides light and heat to the entire system. Orbiting the Sun are 8 planets, each with its own unique characteristics. The inner rocky planets, Mercury, Venus, Earth and Mars, are relatively small and dense. The outer planets, Jupiter, Saturn, Uranus and Neptune, are gas giants, much larger and less dense than their inner counterparts. These giants are orbited by numerous moons, some of which are larger than the planet Mercury. Between the orbits of Mars and Jupiter lies the asteroid belt, a region populated by countless rocky remnants from the early solar system. Section 8, a delicate balance. The solar system's harmony. The orbits of the planets are not random, they follow a precise and predictable pattern. This order is a testament to the power of gravity, which keeps the planets locked in their orbits around the Sun. The solar system is a delicate balance, with each object's gravity influencing the others. This intricate gravitational dance has been going on for billions of years, and it's what keeps our solar system stable. But this balance is not static. The planets, while seemingly fixed in their positions, are constantly moving, their orbits subtly shifting over time. Collisions, while less frequent than in the early solar system, still occur, shaping the surfaces of planets and moons. Our solar system, while ancient, is not frozen in time. It is a dynamic and ever-changing place. Section 9, the future unfolds. A journey through time. What does the future hold for our solar system? As we gaze into the vast expanse of space, we can't help but wonder about the fate of our celestial neighborhood. Over billions of years, the Sun will continue to burn its fuel, eventually exhausting its supply of hydrogen. This process is slow but inevitable, a cosmic clock ticking down. As it ages, the Sun will expand, becoming a red giant star, engulfing the inner planets, including Earth. This transformation will be both magnificent and catastrophic, altering the very fabric of our solar system. Eventually, the Sun will shed its outer layers, leaving behind a white dwarf star, a dense Earth-sized remnant of its former glory. This white dwarf will be a silent witness to the solar system's past. The outer planets, too, will experience changes, their orbits shifting as the Sun's gravity weakens. These distant worlds will drift, their paths altered by the Sun's transformation. The asteroid belt and Kuiper belt, those repositories of the solar system's early history, will continue to be shaped by collisions and gravitational interactions. These regions will remain dynamic, ever-changing landscapes. The story of our solar system is far from over. It is a tale of constant evolution, a narrative that stretches across the eons. It is a story that began billions of years ago, a story that continues to unfold today, and a story that will continue to be written long after we are gone. The universe is a grand tapestry, and our solar system is but one thread in its intricate design. Section 10, still exploring, unraveling the cosmic mystery. Even though we've learned so much about our solar system, there's still so much we don't know. Our journey through the cosmos has only just begun, and each discovery leads to even more questions. What secrets lie hidden beneath the icy surfaces of Europa and Enceladus, moons of Jupiter and Saturn that may harbor vast oceans of liquid water? Could these oceans support life? And if so, what kind of life forms might exist in such extreme environments? What caused the strange hexagonal storm on Saturn's North Pole? This mysterious weather pattern has baffled scientists for decades, and understanding it could reveal new insights into the atmospheric dynamics of gas giants. Are there more planets lurking in the distant reaches of our solar system beyond the orbit of Neptune? The possibility of a hidden ninth planet has intrigued astronomers, sparking numerous searches and studies. These are just a few of that many questions that continue to drive our exploration of the solar system. Each mission, each probe sent into the unknown brings us closer to answering these profound questions. With each new discovery, we gain a deeper understanding of our place in the cosmos. The data collected by our telescopes and space probes not only expands our knowledge, but also fuels our imagination. The story of our solar system is a story of discovery, of wonder, and of the never-ending quest to unravel the mysteries of the universe we inhabit. As we continue to explore, we are reminded of the vastness of space and the endless possibilities that lie ahead.